Hi grade 9s, so this is now our second video on equations. Our first video was on topic 1 but 1.1, so the really basic grade 8 equations that we started with. Now this is still under topic 1 because it is a grade 8 type equation, except they're a little bit more tricky. So I've called this 1.2 and it's equations with x's on both sides and with distribution. So nothing we do in this video should shock you because you have seen it all before in grade 8, but we're probably a little bit rusty. So let's look at example 1. Example 1 says solve for x, and for the first time I have x's on both sides of the equation. Now we don't want x's on both sides of the equation because ultimately we want x by itself. So I can't have x's in multiple places. So I suppose we have to kind of get all our x's to one side. Now what we prefer to get is our x's on the left. Simply it doesn't matter, but that's just what we're used to. So I call these Beyonce type questions. I'm sure she has no idea, but I call them Beyonce type questions, and I'm definitely not going to sing, but I just keep on thinking to the left, to the left. So whenever I see these, I think to the left, the letters need to move to the left. So if I rewrite this, leaving myself a little bit of space, what I'm arguing is that this x on the right hand side, I don't want it there. That to me is in the wrong place because I want my letters to the left and my numbers to the right. So that's why I always think Beyonce, to the left, letters to the left. So if this x has to go, my next question is, how do I get rid of that x? Now, how do I get rid of x? Well, surely I need to take it away. But what you do to one side, you do to the other side. So I'm going to take away that x in the hope that it disappears. But I have to do the same thing to the other side. So how do I get rid of x? I'm going to subtract x, but then don't forget about the golden rule, which said what you do to one side, you do to the other side. So now that I have performed a function on both sides, what I'm going to do is hit pause and just collect up like terms. So on the left hand side I have 2x take away x, which is x, and I have plus 4. On the other side I have x take away x, which was the whole point. I wanted to get rid of that x and it disappears, and so I have minus 1. And the moment I've got my letters to the left, Beyonce, all I need to do now is go back to the type of equations I was doing in the introduction, in that I simply need to get x by itself. So now I have to say to myself, how do I get rid of adding 4? I'm going to subtract 4, but I'm going to do the same thing to both sides. Now this isn't the only way to write it down. So you don't have to write it the way I'm writing it. Lots of people don't actually show the subtracting x on both sides. So I just like writing it like this when we're getting used to it. So in a couple of examples time, I'll show you the different ways that you can write it out if you want to skip some steps. Okay, let's try some more Beyonce type questions. Question B, definitely Beyonce because there's x's on both sides. So I'm going to start writing down a few notes in this example, just so when we're studying we've got some concrete stuff to study from. So why do I call it a Beyonce type question? Because it has x's on both sides. So I've just written in that note there. The moment I see x's on both sides, I say I don't want x's on both sides, and so I click into Beyonce equation mode. And Beyonce equation mode means that I want to get all x's to the left. So immediately I can identify that that 2x needs to go away. So I'm just going to rewrite this question with enough space for me to work what I want to do into it. So I want to get rid of this 2x, and the only way to get rid of 2x is to subtract 2x on both sides. So I just paused for a second and I wrote down a little note there, simply because it's nice to have neat notes when you study from in future. So I've just written there, I need to get rid of that 2x, and so I need to subtract 2x, but on both sides because it's the golden rule. Now the moment I do something to both sides, I like to hit pause and just collect up like terms. So now I have negative 4, I have 3x take away 2x, which is x, and here I have 2x take away 2x, and I'm hoping they disappear because that was the point. Now we're back to solving a very easy equation as usual. So I'm just going to write here solve as usual. Now this particular one is a little bit meaner that it has the minus 4 first and then the x. Now that's not a problem. I still need to get rid of subtracting 4, which means I'm going to add 4 to both sides because then those will disappear. And so finally I'll get x by itself, and negative 1 plus 4 is 3. Now you can always just substitute 3 in and check if you're right. So if this was me in an exam, I would quickly put in 3. 3 times 3 is 9. 9 take away 4. I get 5 on this side. Of course I could use a calculator. On the other side I get 2 times 3, which is 6. Subtract 1 and I get 5. And so it's quite nice to check your answer just quickly, because it tells you immediately if you're happy to move on or if you must just look for a couple of mistakes. Right, so basically those are the steps we're going to follow. We're going to identify that it's a Beyonce question. We're going to get all our letters to the left, and then we're going to solve normally by getting x by itself. So let's look at a couple more examples. Okay, first of all, example C. The moment I look at it, I'm like, hang on, this isn't as messy as it's too messy. It's a little bit messy than it needs to be, because 4x take away 2x can simplify. So I get 2x plus 5 equals 3x plus 1. So definitely a Beyonce question, because I have 3x and I want to get those letters to the left. So in order to get rid of that 3x, I'm going to subtract 3x. Now the moment I do that, I like to pause and collect like terms. So 2x take away 3x is negative x plus 5. Now notice I always leave a gap so that if I need to, add or subtract something, I can. 3x take away 3x disappears, and I get 1. Now I just thought of this to mention this now. Do you notice that I'm not putting any equal signs there? And that's because I'm not simplifying. You can never have two equal signs in a line. So we either leave this blank or we write therefore. Now generally we start getting lazy to write therefore on every line. So we mostly leave it blank. Just please don't put a equal sign there. Now we're back to an easy grade 8 question. So I need to get rid of the fact that there's a negative 1 attached to x, but first all the terms furthest from x. So I need to get rid of adding 5, so I'm going to subtract 5, and then I can worry about the fact that I've actually got negative x equals negative 4, so I can divide both sides by negative 1, and I can get x is equal to 4. Again, I would just check. It's quite comforting to know if you're right. Right, let's move on to another example. Clearly a Beyonce type question because there's x's on both sides. So if I rewrite this with a little bit of space. Now I'm going to show in this example, I'm going to show you how you could write it if you wanted to cut corners. So if you're not cutting corners, I would see 5x and I'm going to subtract 5x on both sides. And so I'm going to collect up like terms. I get 9. 3x take away 5x is minus 2x. 5x take away 5x disappears, and I've got 1. Now this is a fairly standard question. Yes, it's a bit of a weird way around, so I could swap that minus 2x and 9 around, but I don't have to. So I'm going to subtract 9 on both sides to get rid of my 9. So I now have negative 2x is negative 8, and if I divide by negative 2 on both sides, I get the fact that x will be equal to 4. Now that's showing all, positive 4, that is right. Now that's showing all you're working. So let me just put a line down the middle here to show you how you could write this out if you wanted to cut out a few steps. So if I have 9 plus 3x equals 5x plus 1. What a lot of people will do on the next line is say, well, I'm subtracting this, so it's going to disappear, and not write anything. So what they've done there is they've taken away 5x on the right hand side, but they haven't actually shown it. They've just shown the effect. So what they're doing is they're just showing that 1. They're showing the effect of taking it away. So what happens is that I do need to subtract it on the other side. Now that looks like you've just kind of moved it over the equal sign, which a lot of people say, which is terrible. It also looks like you've just put minus 5x on the other side. Actually what's happened is you've subtracted 5x from both sides because you've taken it away from there, and now you've taken it away from the other sides as well. So you have actually done the golden rule. You're just writing down less steps. Now that's not a problem. Now you'd have 9 minus 2x equals 1. So what lots of people will do now is not write this 9. So they've subtracted it away. So they have minus 2x. But that means they need to subtract it on the other side. So simply because it's missing here means that I've subtracted it on the left. So I must go subtract it on the right, even though it doesn't look like I've done that. And now I get minus 8. And most people just divide by negative 2 in their head and get 4. And there's nothing wrong with writing it down like that. You must do whatever makes you feel more comfortable. Okay, let's try E. Definitely Beyonce type question because there's x's on both sides. So I want to get my letters to the left, which means that minus 2x on the right is in the wrong place for me. So to get rid of it, I'm going to add 2x to both sides. Don't forget, you don't have to write it like this. Now minus 3x plus 2x is minus x, minus 4. Negative 2x plus 2x cancels, and I'm left with 1. And so now I can add 4 to both sides to get rid of that subtracting 4. So I get negative x equals 5. And then I can divide by negative 1, which you don't have to show, but that's effectively what I need to do in my head. And I get x is equal to negative 5. Right, so those are your x's on both sides type of questions. They should ring a bell from last year, and so hopefully you feel comfortable with them, and we are going to practice these. Right, let's look at our second example. Our second example is about having distribution inside an equation question. And once again, I'll write down a couple of steps once we've done some examples. So our first example says 2 and then brackets x minus 4 equals 2. Now, probably the easiest way to do this, because there's always lots of ways to do a question, is to distribute in the 2. So I would probably say 2x minus 8 equals 2. Now it becomes a fairly easy question again, because I need to get rid of subtracting 8. So I add 8 to both sides. So I land up with 2x equals 10. And then I divide by 2 on both sides. And this is where I start to become a little bit lazy. And I start writing these things, which you don't have to write them in. So I get x is 5. Don't forget to check. And I just checked that in my head, and I did get the fact that the left-hand side equals 2. So this clearly is the right answer for x. Okay, let's try another one. Question B. Now, why this one's a little bit more interesting is notice there are 2 terms on the left-hand side. So don't forget that one of our first steps is going to be simplify each side of the equation. And within simplifying, we always divide into terms so that you know that the minus 2 belongs to that bracket. So it's minus 2x minus 2, and the plus 1 has nothing to do with the bracket. It's just the next term. Now, personally, I would collect up like terms. So negative 2 plus 1 is negative 1. Now it's back to a fairly easy equation again. So I would add 1 to both sides. So I get minus 2x is equal to 4. And then I would divide by negative 2 on both sides. So that means I get an x value of negative 2. Okay, let's look at another example. And we'll probably start writing down some steps. So if I look at this, I see distribution. And so my first step that I'm going to write down is when each side of the equation isn't simplified, we need to simplify each side. Now don't forget that within simplifying there's steps. So simplify each side of the equation. Now what steps are involved in simplifying anything? The first step, which really needs to be high up on your agenda, is divide each side into terms. That's true for every single simplification you ever do. Always divide into terms. So divide, I can't even write here. So let me try that again. Divide each side into terms. Simply because it tells you what belongs with what. So the moment I divide my left-hand side into terms here, if I divide the right-hand side into terms, it's pretty boring. But the left-hand side, it tells me that the 3 belongs to the bracket and the plus 2 does not. So what we're going to do is we're going to divide into terms, and then we're going to simplify each term. Then probably we can add like terms, but not before we've simplified each term. So here I'm going to get 3x. Now remember, don't put an equal sign there because you think you're simplifying. This is an equation. So I get 3x minus 6. let me get my pen ready, minus 6 plus 2 equals x plus 4. So now that I've simplified each term, my next step in simplifying is add like terms. And once I've done that, I probably get back to a far easier equation. So 3x take away 6 plus 2 is take away 4. And now this is a Beyonce type question. And we know the steps for the Beyonce type questions is get your letters to the left. So get rid of x on both sides. So subtract x. Now I'm going to collect up my like terms. So 3x take away x is 2x minus 4. And this side, x take away x disappears, so I get 4. Now I just need to go back to grade 8 examples, and I need to get rid of subtracting 4, so I'm going to add 4 to both sides. So I'll end up getting 2x is 8, and when I divide by 2 on both sides, I get x is equal to 4. So those are pretty much our steps for when we have distribution. Basically, our main aim is we need to simplify each side of the equation before we can go forward. So we divide each side into terms, we simplify each term, and we add like terms. And those are steps which we probably should have been using for simplification for years now. So after this, I'm just going to write solve as normal, because what happened after that is it went back to a Beyonce type question. Right, now let's go use those steps in the next 2 examples. So the first step was simplify each side, which means I need to divide each side into terms, and that's one term. And I now need to simplify each term. So 1 is simplified. I get plus 2x minus 2, and that equals 3x plus 3. So I multiply out my distribution. Now I need to collect up like terms. So 1 take away 2 is minus 1, and I'd prefer to put the 2x first because that's what I'm used to. And the moment I've done that, I'm now at a Beyonce type question. So I'm going to get rid of this 3x. So I'm going to minus 3x from both sides. So 2x take away 3x is negative x, minus 1. 3x take away 3x is nothing, and I get 3. Now I'm going to get rid of minus 1, so I need to add 1 to both sides. So I get negative x equals 4. And when I divide both sides by negative 1, I get the fact that x is equal to negative 4. Right, in my last example, question E, exactly the same steps. Divide into terms. Simplify each term, so 1, and then this is minus 3x plus 3, and I have 4x x minus 4. So I had distribution on both sides. Now I'm going to add my like terms. So again, I'm going to put my minus 3x first, and 1 plus 3 is 4, and 4x minus 4. So a Beyonce type question, I'm going to get rid of this 4x because my letters need to go to the left. So I'm going to minus 4x. If I collect up like terms, minus 3x minus 4x is minus 7x plus 4. 4x take away 4x disappears, and I get negative 4. Finally, now I need to isolate x. So first get rid of the 4, so I'm going to minus 4 on both sides. So I get negative 7x equals negative 8. And lastly, I'm going to divide both sides by negative 7. And so I get x is equal to 8 over 7. Don't ever worry if you get a fraction example, a fraction answer. And there's nothing wrong with fraction answers, and often we make the answers fractions because then you can't just guess them. Right, now that's the end of this topic, which was basically the more difficult ones from grade 8. So ones with x's on both sides, where you want to get all your letters to the left and then solve as normal. And then ones where you have distribution, and you just need to simplify both sides, and then you get back to the easier type of questions. Well done, guys. Almost on to the fun stuff, which is the grade 9 examples. So keep going.